is kq into xi. Kq is the proportionality constant, xi is the displacement, and as it is acting as a capacitor, we can use a resistance which is R leak, which is a parallel, which is leakage resistance, and a crystal capacitance CCR. So the full crystal is replaced by the charge generator small q equals to kqxi, R leak, and CCR. So these three is the crystal. Then now cable is coming. If cable is coming, then you must have the cable capacitance. So C cable is written here for that. And then if you see that some amplifier is connected with that, so amplifier will have some amplifier capacitance. So C amplifier is written, and then you see that the amplifier has some equivalent resistance also. So R amplifier is written to mention it. So now you see the equivalent circuit consists of a charge generator, a leakage capacitor, all are in parallel, crystal capacitance, cable capacitance, amplifier capacitance, and resistance, amplifier resistance. So if you can reduce this circuit, so we have three capacitance in parallel and two resistance are also in parallel. So three capacitance can be combined as they are in parallel. So C equivalent will be CCR plus C cable plus C amplifier, and R equivalent will be R amplifier into R leakage divided by R amplifier plus R leakage, which is nearly equals to R amplifier, because R leakage resistance is very, very high. And so if you see that R leakage resistance is very, very large, so you can neglect R amplifier, so it will become R amplifier into R decay by R decay, then R decay will be cancel out, so we'll get R amplifier. Okay, so the equivalent circuit will become C and R, and also this charge generator can also be replaced as a current generator. That is very simple. You can see that IC will be equals to dq dt, and if you make it ddt of kqxi, kq is constant, will go out, so it will become kq into xi dot, and left hand side will become the I. So ICR will be equals to kq into xi, where ICR is the current generator from the crystal. So here we can think about the current generating circuit generating current ICR, and there are two equivalent, one equivalent capacitance and one equivalent resistance, and you are getting E0 out of that. Okay, this is the full circuit diagram or equivalent circuit diagram. Okay, here you know that R leakage is the leakage resistance, and kq is the proportionality constant whose unit is the coulomb per meter, xi is the deflection whose unit is the meter. Okay, so now, so you have seen that this for the above transducer, if a static deflection xi is applied and maintained, a transducer terminal voltage will be developed, but the charge will leak. So suppose you give a static distance displacement xi and you maintain that, definitely a EMF will be generated at the terminal and due to the charge generated, but as this act as a capacitance and capacitance is not leakless, the leakage will happen, charge will leak, and gradually the charge will go to zero and the output voltage will come as a zero. Okay, so now if you go for more little bit of kind of more analysis, you will see that whatever I discussed, that q is the kq into xi, and q unit is the coulomb centimeter or coulomb meter, whatever you think. So now if you think about that ICR, what is the ICR? ICR is the current generated, that will be IC, that means current flowing through the, here you see ICR will be the IC plus IR. This is the same thing is written in equation 4.67. ICR will be equals to IC plus IR. So E0 will be equals to EC, that will be equals to integration of IC dt, which will give you the charge divided by C. And then we know IC will be equals to ICR minus IR. So integration of ICR minus IR by C. Okay, here it is. I must put it up, then you can see it. So you see that, so E0 will be equals to EC will be equals to integration ICR minus IR by C dt. So from here you see C dE0 dt will be equals to C dE0 dt. So will be equals to IC minus IR, and that we can write IC, we know K xi dot, so KQ dxi by dt minus IR we know E0 by R. So here if you see that E0 is the output, Xi is the input. So if you see E0 by Xi, which is a function of S, definitely you will get KQ tau D, you will get K tau D or S by tau S plus 1, where K will be equals to KQ by C and tau will be equals to RC. You can write this 4.69, very simple. So you can write this KQ xi dxi by dt. You can write that S xi minus E0 by R, and the left hand side will be C E0 by D E0 by dt. So C S E0. And when you combine all these things, one side it will be x0, another side will be xi. You will get K tau D by tau D or tau S plus 1. But tau will be the time constant RC, K is the static constant, which will be KQ by C. C is the capacitance. Okay. Now, if you see this, so your transducer will be first order transducer. It has a single pole and a single zero. So if you apply a step input here, you will get an exponential rise and it will settle to the steady state. So you have to wait for some times. But as it is a zero, initial it may be dipped. So from the beginning zero, it may not start to exponential and go to steady state. Initially there might be some dip because it has a zero. So, and your homework will be the find out the, so we know the transfer function. Suppose I give a step input, which is xi. Suppose xi is a step input, which is quite possible that initially there is no displacement, suddenly a step displacement happens. And then you give xi as a step input. So you will get E0 will be equals to K tau S by tau S plus 1 into xi, which is a step input, which is equal to 1 by S, and then SS will cancel out, so it will be K by tau S plus 1, and you will get exponential rise of it. So for step response, you will get exponential rise, and then it will settle to a steady state. So after some time, you can take the measurement, which is the E0, and from E0, you can calibrate to know the displacement. So if you can calibrate to know the displacement, you can calibrate it to know the velocity, to know the acceleration. Also, the displacement is proportional to the applied force by means of stress strain law. And if you know the material and the force versus displacement nature of the material that is known, from there you can also measure the force and not only the displacement. Similarly, the force pressure is the force divided by the area. So you know the area, you can also know the applied pressure. So all those things you can know from this transducer. Now tell me if there is any query. So we complete this transducer, piezoelectric transducer, and there are a few more which is as a displacement sensor. In Sahani you will see, in Doeblin you will see, but here the chapter ends. So two more classes we have. There we'll read the temperature sensors. Okay, that is also very important. So in lab you will see many people will ask what is the platinum resistance thermometer, what is the thermocouple, this that. So temperature we'll read, and that will end the syllabus. Okay. So that's all. Now tell me if you have any query up to this point, or if you understood it properly, or if you want me to explain it once more, I can do whatever you like. You tell me if you need anything. Okay, so if you don't have any query or any comment or anything, so I understand that you all understood this. And now you tell me if you have any comment on the Viva quickly, because we are running out of time. If you have any comments on the Viva.
Sir, will the Viva be full syllabus?
Yes, Viva will be full syllabus. That's what I said.
Sir, can we have a post midterm part, please?
No, let it be full syllabus, because syllabus is not that big also, right? It is quite manageable.
Sir, but sir,
NSEM also will be full syllabus. Okay.
yes, sir. That is why we are sir. Can it be post midsem part because sir considering there is a viva sir उसमें बहुत meticulously पढ़ना पड़ता है करने की छोटी छोटी चीज sir and you have already evaluated our pre midsem portion in the pre midsem viva sir like in sem में we can have full syllabus because उसमें sir questions होते हैं तो we can